You know this core structure, right? The amine group, the carboxyl group, that central carbon, and the R group. Well, believe it or not, the difference between a B and an A star in Cambridge biology literally often comes down to how well you understand this exact general structure of amino acids. And it's not just about knowing these chemical facts, it's all about how you actually prove that knowledge on the paper. So let's dive right into this explainer, because mastering this specific topic and the exam strategy around it is often the exact deciding factor for your final grade boundary. I'm going to show you exactly what Cambridge examiners are looking for, and honestly, more importantly, where candidates are throwing away super easy marks.
Okay, picture this. A student writes, amino acids join together to form a polypeptide. Now, biologically speaking, that is 100% true. Hit the nail on the head. But in a 3-mark scenario question, this scores absolutely 0 marks. Zero. Nada. Why? Well, because while the biology is totally correct, the exam technique is completely flawed. This is the classic cold open mistake that cost students their A star literally before they even realize what went wrong. But don't worry, we're going to fix that today.
So what's actually going on here? The crucial point is understanding what Cambridge is actually testing. Ordinary rote memorization revision just completely fails at this level. You can't just memorize flashcards and expect to hit those top bands. The assessment framework heavily prioritizes analytical depth over superficial breadth. In other words, examiners are looking for logical, structured reasoning. They're testing very distinct cognitive domains: your handling of information, your ability to evaluate, and your experimental skills. If you just recite basic biological facts without really digging into the analytical depth of the provided scenario, well, you're going to hit a wall.
And that brings us to the core challenge of topic 2.3, multi-step biological pathways. When we talk about the general structure of amino acids, we're talking about complex sequences where each structural step dictates the next. It's like a domino effect. The primary structure dictates the secondary, which then dictates the tertiary folding based on those R group interactions. It's a sequence. Students really struggle here because they lack a clear problem-solving framework to unpack these multi-step processes logically. They try to jump straight to the final answer instead of showing the systematic, evidence-based reasoning that examiners actually award marks for.
Now, in just a moment, I am going to reveal a highly specific examiner clue. This is pulled straight from the principal examiner reports, and it completely changes how your answer must be structured if you want those top marks. Honestly, it's the ultimate trap. But if I give it to you right now, it won't make a ton of sense. First, you need the foundational framework that makes this clue so incredibly obvious.
Section 1. The Method Mark Strategy. This strategy right here, it's the absolute secret weapon of top-scoring candidates. In complex biological questions, especially those involving the biochemistry of amino acids, examiners award crucial points for the process of problem-solving itself. Think of it this way. You don't just get marks for the final destination. You get marks for proving how you navigated the journey. Here's the exact step-by-step framework you need to employ. Step 1. Deconstruct the given information. Literally pull out the relevant data from the stimulus materials provided in the prompt. Step 2. Break it into logical steps and solve systematically. Step 3. Evaluate and check for reasonableness. Top-scoring candidates demonstrate this evaluative thinking by questioning assumptions and justifying their decisions with hard evidence. If you just jump straight to the answer, you're skipping steps 1 and 2, and you will lose those precious method marks.
And this exact framework applies directly to the mathematical and statistical side of biology, too. Data interpretation is super critical in topic 2.3. You have to extract data from tables, calculate statistics, and actually know which analytical framework to use. For instance, if you're comparing the means of 2 different amino acid concentrations, you must know to select a t-test. If you're looking at categorical data, boom, it's chi-squared. For relationships between variables, you're looking at a correlation test. Knowing the specific data translation secures those method marks because it proves you're solving systematically based on the exact data type provided. Now, keep in mind, this systematic framework also strictly applies to your practical investigations. When you're handed a practical scenario involving amino acids, say chromatography or testing for proteins, you must demonstrate experimental skills. Selecting the appropriate apparatus, following sequential instructions perfectly, identifying anomalies in your observations, and finally drawing evidence-based conclusions. Every single one of these essential steps is a potential mark in your exam. You literally have to prove you can handle and evaluate information practically, not just theoretically.
All right, it is time to close that loop from earlier. Here is the missing examiner clue, quoted directly from the principal examiner reports. The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario.
This right here is exactly why that student's perfectly true statement about polypeptides at the beginning of this explainer scored 0. It was way too generic. It wasn't linked to the stimulus material. If the question gives you a graph about a specific enzyme mutating due to a change in one single amino acid's R group, your answer must specifically reference that enzyme, that mutation, and that R group data. Context is absolutely king.
Section 2. Interactive challenge. Spot the error. Okay, put your examiner hat on for a second and look closely at this real Cambridge-style exam scenario. The flawed answer simply recites the textbook definition of an amino acid structure. It mentions the amine group, the carboxyl group, and the central carbon. Great memory, sure, but a terrible strategy. It completely ignores the provided data table. Now contrast that with the top band answer. This student deconstructs the prompt. They actively extract specific numbers from the table, they calculate the relevant statistics to show the difference in R group interactions, and they justify their reasoning using correct terminology like disulfide bonds or hydrophobic interactions specifically linked to the scenario provided. I mean, the difference between these two answers is literally the difference between a C and an A star.
Section 3. Top 3 examiner warnings.
Pay attention here because these aren't just guesses, these are the direct repeated warnings from the principal examiner reports year after year. Number 1, forgetting to include units in calculations. When you calculate an RF value or a concentration, leaving the units off or writing the wrong ones instantly costs you easy marks. Number 2, failing to double-check units in terminology. Using peptide bond when you actually mean hydrogen bond in a secondary structure discussion will absolutely tank your score. You must present with correct terminology. And number 3, the ultimate sin we just discussed, writing answers that are not specific to the context given. These 3 mistakes are totally devastating. But the good news? They are completely preventable if you just use the deconstruct, solve, evaluate method.
So, what should you really take away from this explainer? First, make absolutely sure you practice these concepts using actual past paper questions. Second, aggressively apply the deconstruct, solve, evaluate method to every single multi-mark question. Don't just write, plan your process. And third, always link your biological knowledge directly back to the specific context and stimulus material provided in the prompt.
But wait, here's a kind of terrifying thought. What if you do everything we just talked about? You memorize the amino acid structures, you deconstruct the data, you use specific context, and you still get capped at a B grade. How is that even possible? Well, it happens all the time, simply because the student misunderstood one single command word in the prompt. If the exam says evaluate and you just describe, you lose half the marks immediately, no matter how good your biology actually is. Command words literally dictate your final mark band.
So, are your command words capping your potential? You really cannot afford to lose A-star marks over a simple misunderstanding. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to master your Cambridge examinations and instantly click on our next explainer to decode the exact command words that will unlock your top grade. Don't let all that biology knowledge go to waste. We'll see you there.